as well as carrying out reactions between a metal with acid or water. We can also look at the reaction between a metal and a salt solution to determine the reactivity of that metal. To do this reaction, we take the solid metal and react it with the salt that's been dissolved in water in order to form a solution. As we know, a salt is an ionic compound formed between a metal and a non-metal. Therefore, a salt solution contains a compound that's been dissolved that contains a metal. And as it's an ionic compound, it will contain the metal in the form of a cation. And this is what we can see in this diagram, which shows a salt solution made up of water and our dissolved salt, which will exist as anions and cations. As always for the reaction between a metal and a non-metal, in the formation of this ionic compound that we've then dissolved in water, our non-metal will form an anion by gaining an electron, and our metal will form cations by losing electrons. It's the fact that a salt solution contains metal cations which makes it useful for determining the reactivity of a metal. This is because a more reactive metal will displace a less reactive metal from its compound when it's added to the salt solution. Before we look closer at what this means, we can just quickly think about some examples of salt solutions. For example, you can make a sodium chloride solution containing NaCl or sodium chloride, which has been dissolved in water and is therefore aqueous. You could also form a solution of magnesium chloride, which would also be aqueous, or, for example, potassium bromide. In each case, we formed an aqueous solution of an ionic compound made up of a metal and a non-metal, where the metal will be found as a cation, Na+ or K+ for potassium and sodium, or Mg2+ for magnesium. So, what do we mean when we say a more reactive metal can displace a less reactive metal from its compound if it's added to a salt solution? This observation is related to the fact that the more reactive a metal, the more happy it will be forming a cation, and that our salt solution contains cations. Here we have a small part of the reactivity series, which as always is organised so that the reactivity decreases as you move down the series, showing us that potassium is more reactive than sodium, which is more reactive than lithium, and so on. We just thought of an example of a salt solution as magnesium chloride, which has the chemical formula MgCl2. What happens if you react a solution of magnesium chloride with a more reactive metal?
Hi guys! To continue watching this video and unlock hundreds of other super concise and exam board specific GCSE chemistry and combined science videos, just click on the Snap Revise smiley face. Join me today and together let's make Chemistry at GCSE a walk in the park.